For years, we believed Europa's ocean was sealed beneath miles of impenetrable crust. But new readings from the James Webb Telescope have confirmed a massive surge of carbon dioxide in a specific region called Tara Regio. But this is the shocking part: this gas isn't surface debris. It is bleeding up from the deep, and this fact has shocked scientists. This discovery shatters the old timeline for finding alien life. This signal has forced NASA to rethink the Europa Clipper mission, and things are changing for the worse. Europa is one of Jupiter's largest moons, instantly recognizable by its smooth, fractured, icy shell. It is scientifically vital because beneath that frozen crust lies a massive global ocean containing twice as much liquid water as all of Earth combined. NASA is obsessed with Europa for one reason: habitability. Unlike Mars, which had water billions of years ago, Europa has it now. Combined with chemical nutrients and energy from tidal heating, this ocean likely possesses all the necessary ingredients to support life today, making it our best shot at finding biology beyond Earth. NASA has kept a relentless watch on Europa, knowing that if life exists nearby, this frozen moon is the most likely suspect. To see through the glare of Jupiter, scientists have had to get creative, combining legacy data from the Galileo spacecraft with the modern high-definition gaze of the Hubble Space Telescope. By applying advanced spectral analysis to this combined dataset, they dissected the light reflecting off the ice to identify exactly what the surface is made of. And that is where the story changed. The analysis revealed chemical signatures that have no business existing on a frozen, irradiated shell, specific salts, and heavy concentrations of carbon dioxide. In the vacuum of space, these compounds should degrade or disappear. The fact that they are present and concentrated in younger, chaotic terrain leads to one unavoidable conclusion: they aren't coming from space. They are bleeding up from below. To understand the gravity of this discovery, you have to look at exactly where the carbon was found. It was concentrated specifically in Tara Regio, which is a chaotic region where the ice has recently shattered and resurfaced. This location is the smoking gun because it proves the carbon didn't fall from the sky. It bled up from the deep. For biologists, this is the ultimate green light. Carbon is the backbone of all known biology, and by confirming that Europa's ocean has a native supply, we've removed the biggest hurdle for habitability. But the implication goes beyond just chemistry, and in reality, it proves access. The fact that this ocean carbon made it to the surface means the ice shell isn't a hermetically sealed coffin. It is a permeable, active system that is cycling material right now. We now know the ocean has the water, the energy, and the building blocks for life. And critically, we know the door is unlocked. So does that mean Europa is already covered with life? Is there a civilization hidden below all that ice? At first glance, Europa looks like a shattered marble, the smoothest object in the solar system, crisscrossed by long red scars called lineae. But don't let the beauty fool you. This is a frozen hellscape where surface temperatures plunge to minus 370 degrees Fahrenheit. It is a vacuum-sealed wasteland, bombarded by enough radiation from Jupiter to destroy complex organic molecules on contact. So why do scientists think this is our best bet for finding life? The answer lies in gravity. As Europa orbits, Jupiter's massive gravitational pull violently stretches and compresses the moon. This constant flexing creates friction deep inside the core, generating massive amounts of internal heat, which is a process called tidal heating. It is this mechanical engine that keeps the subsurface ocean liquid, preventing it from freezing solid. This means that down in the dark, life wouldn't need sunlight to survive. Instead, it would thrive on chemical energy churning up from hydrothermal vents on the seafloor, creating an ecosystem eerily similar to the one we find in Earth's deepest trenches. However, Europa still remains one of the deadliest environments in the solar system. While the subsurface ocean might be a paradise for microbes or even space fish, The surface is a kill zone for humans. First, there is no atmosphere to breathe or protect you. Second, the surface temperature sits at a bone-shattering minus 260 degrees Fahrenheit, and the most ruthless killer is radiation. Europa orbits deep inside Jupiter's magnetic field, which acts like a particle accelerator, blasting the moon with ionizing radiation. A human standing on the surface without massive shielding would receive a lethal dose in under 24 hours. So while we might find alien life swimming in the dark oceans below, humans will never build cities on the ice above. We will visit with hardened robots, or not at all. And there's a reason why the scientists believe Europa is alive. You see, the moon is actively trying to push its ocean into space. This is evidence of a phenomenon called the plumes. A plume is a column of material, such as gas, dust, or liquid, that is forcefully ejected from a celestial body into its atmosphere or space. On Europa, these manifest as massive geysers of water vapor and ice crystals blasting from the subsurface ocean through cracks in the frozen crust. This phenomenon is crucial because it offers scientists a way to sample the moon's hidden waters directly without ever needing to drill through the thick, irradiated ice shell. Hubble and Galileo data suggest that massive geysers of water vapor are erupting from the surface, shooting up to 100 miles high. And this is proof of pressure. On Earth, deep ocean vents are driven by heat and pressure, creating nutrient-rich chimneys where life thrives in total darkness. On Europa, the gravity of Jupiter squeezes the moon so violently that it creates similar internal pressure, forcing mineral-rich water up through cracks in the ice. This matters because it connects the surface to the seafloor. If there are microbes swimming around hydrothermal vents at the bottom, these plumes could be carrying them to the top. It means we don't necessarily need to drill through 20 miles of ice to find life. We might just need to fly through the mist and catch it. To answer these questions, NASA is sending its heavy hitter. Launched in October 2024, the Europa Clipper is the largest planetary spacecraft NASA has ever built, with a price tag of $5.2 billion. It is currently speeding through the dark, using gravity assists from Mars and Earth to sling itself toward the Jupiter system for an arrival in April 2030. Once it gets there, Clipper won't be able to land as the radiation is too deadly. Instead, it will perform 49 high-speed dives, swooping as close as 16 miles above the surface to scan the ice and ocean before retreating to safety. Its mission is to measure the ice shell's thickness, map the surface composition, and most importantly, hunt for those plumes. Because if Clipper can fly through just one of those water vents, it can taste the ocean without ever touching the ground. And that will answer all the questions we have right now. But for that, we have to wait until 2030. NASA has been incredibly careful not to formally announce life on Europa, and that silence is entirely intentional, because this isn't just a scientific milestone. Rather, it is a philosophical paradigm shift. If we confirm that Europa's hidden ocean is habitable, and more than that, there is life in the Milky Way other than humans, we are forced to admit that life isn't some cosmic accident that happened once on Earth, but a fundamental property of the universe that emerges wherever energy, water, and chemistry align. But you see, it's not as scary as you might think when you hear aliens. Rather, it's more interesting. When we imagine alien life, we often picture complex creatures swimming in the dark, but the reality of Europa is likely far more subtle and microscopic. We aren't searching for complex life forms that would wave at a camera, but rather for hardy, single-celled organisms that cling to the rim of thermal vents deep on the ocean floor. Because sunlight can't penetrate that miles-thick ice shell, these organisms wouldn't rely on photosynthesis like plants on Earth. Instead, they would be chemosynthetic, deriving their energy directly from the chemical soup churning out of the moon's rocky core. This means the aliens we are hunting are likely akin to the bacteria found in Earth's deepest trenches, invisible to a telescope and undetectable from orbit, yet representing a biological revolution that would redefine our understanding of the universe. While they might just look like sludge to the naked eye, Discovering a second genesis of life, even in microbial form, would be the most significant scientific moment in human history. While finding simple carbon would be scientifically interesting, the Clipper's true target is complex organic molecules, specifically amino acids and fatty acids, which serve as the architectural blueprints of biology. Identifying these complex chains wouldn't give us a photograph of an alien, but it definitely would reveal the undeniable chemical shadow of one, confirming that the ocean is a dynamic system that is actively cooking, and that would change everything. This possibility drags us into a reality we aren't quite ready for, forcing us to ask not only if we are alone, but also what right we have to intrude on a fragile, alien ecosystem. The danger isn't just finding life, but accidentally contaminating it with our own microbes, which transforms these abstract sci-fi ethical debates into immediate practical problems for mission control today. What Clipper might find would most likely change life on Earth as we know it. NASA wants to ensure all facts before committing, because life may not be rare. It may emerge anywhere energy, water, and chemistry align. And with the whole Europa situation, we have more than enough proof of that being true. Do you really think we're alone in this whole universe? Let us know in the comments, and we'll catch you in the next one.